Okay, so now we're jumping into types of airspeed. We have indicated, calibrated, true, ground speed, and then we're gonna cover the V speeds. So first we have indicated airspeed. Just like the altimeter, you read it off of the indicator, but in this situation, it's the airspeed indicator. When, say you're flying, when ATC tells you to maintain 110 knots or below, you look, and that's based off of your airspeed indicator. Next we have calibrated airspeed, which is your indicated airspeed corrected for installation errors. So that means your pitot tube. So your airspeed is found through your static port, which is on the side of the plane, and your pitot tube, which sticks out under the left wing of the plane. It's like a little metal rod. So those two things work together to get your airspeed. But the installation errors, if you're in a climb, there's gonna be, so there's a little tiny hole that's in the opening of the front of the pitot tube. So here, I'll actually pull it up so you can see it. Pitot tube. Images. Plane. Okay, so it looks like this pretty much. Oh, right there, right here. That's what it looks like on our Cessna. I'll show it to you guys too. So this is the pitot tube. The small hole is up front. So the air is coming into there, and that's how your airspeed's calculated. But what this is saying is that when you're in a climb, the air won't necessarily be coming full into the little opening. It could just be like skimming it. So that's what the calibrated airspeed is for. And there's a chart in the POH that tells you the corrections for that. Also, you can figure it out on your E6B. Then you have true airspeed, which is your speed relative to the mass that you're flying through. So with this, an example is as you go up in altitude, your true airspeed is going to increase. So some people might think that's weird because as you go up higher, there's less dense air, so you won't perform as well, but that's not true because once you go up, there's less air molecules, which means you're going to have less drag on the plane, so you can go faster. So even though you do get a slight performance decrease, it's not as much as the decrease in air density, so your drag decreases more than your engine loses pretty much. So as you go up in altitude, you have a 2% increase in speed per 1,000 feet density altitude. So without doing the math or anything, at sea level, say you're at 100 knots, once you go up to 5,000 feet, you're gonna be at 110 knots, and then going up to 10,000 feet MSL, it'll be at 120 knots. There's math behind that too, like doing a 2% increase for each 1,000 foot, but I didn't write that out. Next, we're gonna talk about ground speed, which is the speed you're going over the ground. So this is how you can compare your speed to how fast the cars are going if you want to. So what this is your true airspeed corrected for the wind direction and velocity. So where it's coming from and how fast it's going. You can find your ground speed using your E6B. I'll go over that in a second. So say you're flying at 100 knots and you have a 20 knot tailwind, your ground speed is going to be 120 knots. Now we're going to look at the E6B. Okay, so this outer ring here is your distance. This inner ring of numbers is how long it took you. So say you went 20 miles in 10 minutes. Your ground speed is wherever this big arrow is, so your ground speed would be 120. Okay. So that's ground speed. Now we're going to talk about the V speeds. So V speeds are memorized speeds that you want to know, just for the safety of the flight. So there's a list of different ones here that we use in our 172, so I'm going to go over those. And then once I cover them, we're going to look at the airspeed indicator where some of these apply. So VSO is 40, and it's for a dirty stall. It's just a funny way of saying it. Or how I think of it is stuff out. So that means what airspeed the plane will stall at when the flaps are down. VS is stall speed in a clean configuration, so your flaps are still up. VX is your best angle of climb, 62. So that's gonna get you the greatest amount of height over the shortest distance. Then there's VY, which is 74, which is your best rate of climb. So you're gonna go like gain the most altitude in the shortest amount of time. So this one is most altitude gain in shortest horizontal distance. This is the most altitude gain in the best time. You look confused. Okay. Then there's VA, which is 90 to 105, which is maneuvering speed. We've already covered that. VFE, flaps extended, is what I like to think, 85, 110. So once you're below 110, you can put in your first notch of flaps, which is 10 degrees. Once you're below 85 knots, you can put in your second notch of flaps, which is 20 degrees. Then there's VNO, which is 129, which is your natural structural cruising speed. And then you have VNE, which is 163, and your never exceed speed. Never exceed. So now we're going to look at the airspeed indicator. Okay, so with the things we just talked about, I guess I'll kind of go backwards. So your red line right here is VNE, your never exceed speed, which is at 163. This is your caution range, which starts at 129. So you can fly in your caution range during normal operations when the air is smooth. This green is your normal operating range. Here is your VSO, so where you'll stall with your flaps in. The green right here is your VS, where you'll stall with your flaps up. And then 85 right here is flaps extended. Okay, so covered indicated caliber.
Best glide.
Oh, right, best glide speed. I didn't write the number. Well, it's 68. So if your engine were to fail, you would want to pitch for 68 and try to hold that, because you'll be able to go the furthest amount of distance without losing. Well, you're going to be losing altitude, but you can go. It's the furthest you'll go for how much altitude you lose. Does that make sense? Mm-hmm. Okay. So we went over indicated, calibrated, true, ground speed, and then the V speeds. You guys have any questions? Okay.